there we go. Now we've got a stream going. Okay. Gotta fix up two things here. I'll leave that. This is too bright. Let's tone this down a bit. Let's do like a fall glow. Bring it down a bit. There we go. That looks pretty good, I'd say. All right, we've got good audio. We've got the screen going. Now we're cooking. Now we got stuff. Ugh, okay. There we go. All right, so I think, oh man, now I gotta, okay, so I am in the middle of working through some triangulation algorithms. The reason is for working with shapes like this. Ooh, we're getting a weird flicker on this render here. I'm not sure why that is. Maybe that'll go away. But I have this approach for doing extrusions with surfaces, and I can triangulate the surface, but the cap elements of the extrusion I need to be able to triangulate from the Clojure context, and I don't have that working perfectly yet because of concave polygons. So I want to implement a hopefully simple algorithm called ear clipping. It doesn't lead to good triangulations necessarily, but it does work fairly quickly, and it does give you the ability to triangulate concave polygons. And then using that, I could maybe come up with a hybrid approach. So I can use a Delaunay triangulation to get a triangulation of the point set, and then I can use the ear clipped polygons to guarantee concavity, and then doing some internal checks between, or something to that effect. I don't know. I'll have to see what's what, but that's an idea I have as a starting point. So I've worked on a few things. So I've got the ability to remove collinear points. So this here is a test to indicate that that's working. So I've got, so all these white points are the points that are removed via the collinear removal cleanup here with remove collinears. And I was just doing some quick sanity checks on the corner condition. So a corner is the middle vertex of a vertex triplet, and it can either be collinear, so it can be flat, which we want to remove those cases. It can be convex, where the angle between the two edges of the corner are 90 or less, or it can be reflex, where the angle is greater. And there's actually a great way to use the cross product. Sorry, something in the way there. To use the cross product of, I'm in 2 dimensions, but if we assume the z value of the vectors of the edges is 0, we can use cross product, which is defined for 3D vertices, to get, well, I made this cross k helper to just get the third component, the ij, the k component of the cross product result. which is defined over 2 dimensions. It's like a pseudo cross product. Point is, if that's negative, it means one thing. If it's positive, it means another. And if it's 0, it means it's collinear. So I can use those to do quick math checks for collinearity without even having to do angle calculations, which is really nice. Hopefully that can make some of these algorithms quicker and more reliable, because my angle computation stuff, I'm still not sure that I've thoroughly tested all the corner cases. So if I can have this reliable test that runs quicker and is consistent and easy for certain checks anyway, then I'm really happy with that. So that's the goal for the day, is get an ear clipping algorithm that works for the concave polygons I want to consider, and then feed that algorithm back into the meshing approach I've got for this blend extrude, and just see where things go from there. That's the goal. I do know, so this blend extrude looks really cool, but I'm quite sure there's some problems in the implementation, and I want to, if I have the time, see if I can explore that and start to fix the errors that arise from some of those assumptions I built into the blend. Okay, so that's where I'm at. Here, I remove collinears as a work. No, that's good. I'm now ready to start coming up with an approach for let me an approach for the ear clipping. Okay, so the way to do that, I might need a paper to help me with that. Okay. Scrap paper on a clipboard. That's how I roll. All right. If there's anyone tuned in, feel free to ask questions, say hi in the chat, anything like that. I am here to have a good time, get some code done, and just chat about Clojure, programming in general, you know, your projects, your ideas, anything like that. So feel free to hop in the chat and say hello. I am usually friendly. Try to be. All right, so the ear clipping algorithm, just let's see. How do I want to do it? Okay, so clipping a single ear off of any polygon should result in 2 polygons, right? One of them will be a triangle, and then the other polygon will be the same shape with that triangle cut away from it. So let's just start with that and kind of take it one little bit at a time. So the conditions necessary, okay, there's 2 conditions. two conditions for a vertex to be clippable. The corner at the vertex must be convex. Easy to check that with this corner condition here. So that's pretty straightforward. The second condition is that the triangle defined by the vertex and its neighbors, prev and next vertices in the cyclical list, must have no points inside it. Okay, so what I can do is let's make a tries. We'll start there. We'll make a we'll just make the first tries, and how do I want to do it? Let's thread points through remove collinears. Although actually, I might not need to, because what I could do instead is something to the effect of, let's think about this just a bit differently. Let's do thread points through filter, and we'll filter by let's think about this. I don't know if this is gonna work. So we want to keep only I think this might work. We'll try it. Also, by the way, let's do this to be, so indices, we're gonna do this sort of mapping trick. So we're gonna do zip map, use the points as the keys, and then create the values for those keys to be the indices, so that we can quickly convert between the points and the indices from the original point list. That way we can preserve the order while still moving things out of the list. Not sure if that made any sense, but maybe I can explain it better in a video or something like that. Anyway, so we're gonna zip map points as keys and then range count points. So that it's just a map where you can pass in the point, and then the map will give you back the index value of that point in the original list of points. So you can then run that back through, you can dissociate from that map any points that no longer are needed. Then you can get the values from the remaining map. So then you have all the indices, and you just get those indices from the original point list to get the reduced point list. Does that make any sense? I sure hope it does. I think it'll be okay. Let me think about this. Okay, so we got indices just in case we need it, but let's focus in on this. So we want to filter and get only the points that are convex, right? I think that's fine. So let's do that, but we've got to run corner condition. Not sure if that's gonna work. Find out in a minute, really. Okay, so that's actually the tries. That's all we need. Oh, you know what? Let's make this just a little more readable. Wait, no. Well, let's see if that's gonna actually do what we think it is. Okay, so let's assume we've got the tries. What I want to do is there's one thing I have to check actually. Let's do B is first of A, so B is a point, yeah. I need to check point inside, given A and B. Okay. Oh, this is also not split up into tries yet. I have to do one more thing here. Actually, you know what? Let me clean this up just a bit. Okay, let's do it like this. X points. Filter by running this function over the points list. Then tries is just going to be partition 3.1 of concat x points take 2 x points. There we go. So now we've got the triangles list. Okay, then we need to do first of remove, where here what we need to do is run the function given a triangle. Let's make a little function inside here. Try function is gonna take, it's gonna be a function that takes the triangle A, B, C. Actually, I can just leave it like this, try. And what it's gonna do is map, it's gonna do try, it has to be okay, contains any. given this triangle, right, you're just checking if any of the points are inside. So the way to do that is nil. No. What's the best way to do it? Seek. Brain is off right now, but we'll figure it out. We'll check if this works actually. But the whole idea is just this: map point inside, right? And what it is try over all of the points like this. Okay, so then all I need is first from remove using contains any tries, and that should give me a triangle. So we'll start there. This might totally flop, but let's try it, right? There's no reason not to. Let's redefine A to be a regular polygon with a radius of 108 points. Okay, so it's a regular shape. So let's do show 2D of A. It looks like that. This is just because it's drawing it as a polyline. If this is closed, it's a polygon. All right, let's see if we do clip one ear, if this will work or fail. It fails, and that is not too surprising. Let's wrong number of arguments 2 passed to corner condition. Right, so I did things in the wrong order here. That's not, it's pretty obvious when I think about it, but that was just a mistake I made, and that is okay. Right, so I can actually do things this way. Filter with convex the tries list. Let's rewrite this. So we don't need this X points thing. Okay. So the cycled point list gets filtered or passed through partition 3.1, and then right here we just do filter that result with it has to be like this again. Convex from the result of corner condition apply corner condition to the triangle being passed in. Let's get rid of X points. Okay, is that better? Oh, right. Okay. Okay, so it does split into tries at least. That's good. Right, so now we need to check. Okay, so this was, I think this was the right approach. Let me think about this. Do I have to invert this? I don't think I'm doing this right yet, to be honest, but let's kind of explore this. Oh, I'm doing this a bit wrong though. This is not correct. Oh my goodness, 1 second. Okay, so I'm doing this wrong. I have to create triangles without changing the point that I'm triangulating around, right? So what I've actually done here is create a bunch of corners. So this is actually wrong. I actually just need to do... I just need to get the first point from the list that is convex and then go from there. So let's see. I actually don't know that I can do this. Let me think about it. Well, let's just do, let's keep going with this thought. Maybe I'll find it's totally wrong. But what I've done wrong here is what I actually need for to start is, so I need to call these corners instead. And then what I need to do here is get only the convex corners. And then I can do something like something like that. Possible ear is the first of the corners. And then from there, what I need to do is define tries to be basically you think about this. No, this, I should... Let me sanity check myself here. Okay, so what I want to just do here is conditions. I'm just going to do map try function. No. C function. The corner function is going to be a function taking the corner, and it's just going to run. It's going to just return No, let's do it this way. Let's do filter point inside, which will take the corner, and then the filter will run over the original points list like this, which means now if I just do map corner function over the corners, then I should get, it should output something, and that might help me think about this. Let's go. Okay, so I mean, it outputs something, right? But there are no points inside any of the corners, which is that right? I guess so, eh? Yeah, so yeah, so I actually have to do this, not seek. That should work now. Okay, so map clear. So this should, true, right. So here, right, what I should be able to do is filter, so I could use any of those. Yeah, so here I could just do first. So it gives me 1 point. That's pretty good. Okay. That's a start. I don't know that it's guaranteed to be correct, so let's kind of think through that for a minute. But we can make a clip one ear helper maybe. Although what I actually should do is create some kind of data structure, so it should be like this. Should be try is this thing. Ooh, wait a second. I should maybe make this a little better. Like this. Try is first filter clear corners. Okay, so the try is try, then try indices. First of all, points is points, endpoints. Yeah, we'll do that. So endpoints is going to be vals of the result of dissoc from indices it's like this: map get from points, the index that's derived from vals of apply dissoc to indices and try. Okay, that should be the new points. Try is that. Then try indices is actually just going to be map v map v get from indices try. Okay, let's see if I'm right about that. Okay, so the original points are the points are this list. This went wrong. Try indices worked. It just took the first triangle, or the first 3 points, which is pretty nice. That's good. Okay, so something went wrong with n points, which is fine. I just have to figure that one out. So if I do let's just start like this. Yeah. I know. I'm confused by that. I'll be right back. I'll figure that one out though. All right, back at it. Oh. No. Oh. This is what I need to do. There we go. That's what I'm looking for. Okay. So let's also turn it into a vector to be safe here. So the original points end up as a vector. Okay, we've got everything necessary to kind of build out a clipping approach from here, I think. Right? So all I ever need to do is recursively clip one ear, and then every time I go, I just have the new points, and I just save the triangles from there, and I guess the try indices and everything like that. So now I just need to build the recursive clip ears, basically. So define clip ears points list. Just trying to think about the data structure I want to have built into this. So I'm gonna run clip ears with points tries. Okay, let's do something like clip ears. Points triangle list is an empty list. Let's start with that. I think that's fine to start like that. And now we're gonna go here. So we want to take points, tries. That's the initial setup. So we're gonna do there's one problem actually here. I actually only want to dissociate. So I need try, right? But I can only dissociate the corner point. I need to keep all of the other points in there because they're not gone from the poly. That's yeah, it's actually really important that I keep them in there. Otherwise it is wrong. Okay, so what I want to do is actually just do dissociate from indices, the second of try, like that. Which, so points and endpoints, there should just be one point missing from it. So this here, this second point, 70, 70, 70, is gone. So that looks correct. So that's good. That's what we need. So the stopping condition is what I'm trying to think of right now. So in through every iteration here, the points, so tries just get accumulated, and then there's some stopping condition. So if the remaining points, if the count of points becomes less than 3, then you're done, right? Then, for the time being, let's return points . Let's just do that for now. That's super simple. That's the return. We'll fix it up and make it work more efficiently with each other once I've got it working at all, and then I can think better about the architecture of it. I'm okay with that. As long as I can get it working, that's the important thing for now. So, right. Next. So if that stopping condition is met, you return everything because you're done. Oh, no, that's not quite true. You would actually need to return tries where you actually, if the count of points is 3, that implies that the 3 remaining points are a triangle. So all you need to do is return tries with that concatenated onto the list, right? I think that makes sense. So we'll just do that. Concat points to tries like that. Otherwise, you need to let some things and then recur with the new points, new tries. Okay, that's the whole, well, that's the basics. So we'll go here. What we can do is let's see, how does this work again? Keys, new points, try, be clip one ear from the points that gets you those keys. So then you just pass new points onto there, but then new tries that you have to change it up just a little bit. So new tries is going to be concat oh hey, Yuka with data, thanks for the raid. I just noticed that now. Appreciate that. I don't even have to, this is, concat is wrong and it should actually be conj, I think. Hey, Yuka, how are you? I hope you're doing well. Thanks for the raid. Not sure if you heard that. I said it just a second ago there. Hey, Pedro and Shendali, Shendanieli. Sorry if I get your names wrong. Quickly trying to read them there. Oh my goodness. Thanks for the raid. Welcome everyone. How is everyone doing today? Please let me know if you're doing well. Feel free to talk in the chat about programming, about how your day's going. Keep it friendly, but it's all good. Hey, look at all that. Hi. Those are fun. Oh shoot, I'm gonna sound like an old man. Emoticons? No. Jeez. Emotes. That's the word. Dang. I'm an ancient man. There we go. Oh, sorry. There we go. Emote, that's the one. Thank you. Oh my goodness. Hey Yuka, I'm if you're raiding, it might mean you have to go soon. But what were you working on before you raided? If you have time to tell. If you don't, that's totally cool too. But curious what brings other people here from other projects and stuff like that. You know. the youths these days and their fancy internet emote pictures. Back in my day, there were nothing but characters and text. I'm not even that old. Like, I should know what the word is. Oh my goodness, what a day. What a day. That's Monday for you sometimes. You know what? I'm okay with it. I can handle it. The fact that I'm getting older. I know those days too. Back in my day, the smiley face emote was a colon and a closing paren. Yeah. You know what? I still type that out on my, like, when I'm sending iPhone messages, and it doesn't correct it or like replace it with a smiley face. So I still do that from time to time. Don't have to rush out today. You'll stay here to keep working. Oh, cool. Nice. Well, I hope your work goes well there, Yuka. And as always, I really appreciate a raid. That's always fun to see. And other people tuning in is always great too. I just hope everyone's having a good time, you know? Getting some work done, relaxing, whatever it is. Just glad to be here, writing some code with everyone here, you know? I still use, oh, what is this one? Oh, colon, backslash or forward slash. Yeah. You know the kids these days. They use the colon close paren as a passive-aggressive smile. Oh my goodness. All these etiquette rules about emotes. I can't... Don't use that with Gen Z kids, eh? Oh, okay. Good to know. Also, hi. Hey, Thrashton. How's it going? There are too many. There are too many etiquette rules. I can't keep track. I'm just gonna do my best to be sincere, and I feel like people will pick up on that. The smiley thing is just in Russia. Shendanieli, Shendanieli. I don't. Sorry if I'm getting the name wrong, but thanks for the follow. I appreciate that a lot. It's really nice. Thrashton, yeah, you mentioned you moved. You're in. Wait, don't say it. I know it. Estonia. It's Estonia, right? Yes, I got it right before. Nice. Yeah. Yeah, you tuned in before you moved, you mentioned it, and then you tuned in kind of after you moved, and said the move went quite well. So I was really happy to hear that. So yeah, hopefully you're kind of settling in and enjoying that. Settling in, nice. Glad to hear it. Shindanuli, I'm mainly R and Python programmer. I don't do Clojure. Oh, okay, yeah. So I've never done R. I know of it. I've done Python in the past, and then I decided to teach myself Clojure, and I've kind of stuck with it for a long time. Not because I don't like Python. I really love it. There's a lot of amazing libraries for all kinds of stuff in Python, as I'm sure you know. But I was just really intrigued. I wanted to learn a Lisp language, and Clojure was a modern one, and Rich Hickey had really cool talks and ideas. And I was like, you know what? Seems like a smart group of people use this language. I'll see what I can do, you know? So that's where I came into Clojure. Is Clojure compiled / interpreted? Yes. To be about the modern one part. Oh, Thrashton, you're gonna bring your Common Lisp back into it? You could go ahead. Hey, so everyone in the chat, if you haven't heard, Commander Thrashton is all about Common Lisp, and they evangelize it like nobody's business. So the compiled interpreted, here's how it works. It's compiled, but you can run it in a REPL. So if I, for example, in this REPL here, type multiply 2 by 2, and I press enter, it takes that S expression, compiles it, and runs the bytecode and immediately sends it back. Learned a bit of Scheme in HS. I assume HS is high school. Is that correct? So it is compiled in the sense that every expression is immediately compiled into the JVM bytecode, and then it's run immediately. But yeah, high school. Gotcha. But so it's running it's running it all and compiling it all kind of on the fly. So it's REPL, read, evaluate, print, loop. So that's learned. You saw it in high school. Yeah, fair enough. Probably you learned a little bit of it, and there's, it's one of those things where depth takes time, right? You have to really dig in if you want to learn it more deeply. But, I get I'm picking up what you're putting down. But there are environments where you can run Clojure or Clojure script and it is interpreted. So for example, oops, I'm pressing the wrong buttons here. Let's go Bork Dude Psi. So Psi is simple Clojure interpreter. Oh, that's so this library here. It's a way in which you can run Clojure code, and so this is interpreted. It's a little bit different than the REPL, the compiling REPL on the JVM. But yeah, so I guess it's a dynamically used language, right? So you can compile little bits and run it all live. So it feels interpreted, but is technically compiled. But I'm also not an expert in the technical minutia of how that all works. So take that with a grain of salt, right? But what you see here, if I send an S expression to the REPL, it compiles it, runs it on the JVM, sends back the result. That's what's happening there. So it's compiled in that sense. I used to use Emacs, and then you went to VS Code. Emacs Lisp was just too much. You know, honestly, there's no reason to stick with Emacs if it's just too much for you. Like, I enjoy it because I got it set up in a cool way that I enjoy using. I like org mode. I know just enough Emacs Lisp to customize it to what I want, and then I learned how to use it, and it worked nicely for me. But yeah, if you don't like or don't want to learn Emacs Lisp, then don't learn Emacs, right? Like, there's absolutely nothing wrong with that. VS Code, powerful tool, and getting better. Some might argue there are some things that are better, some things that are worse. Point is, very powerful tool, all kinds of great plugins, gets you up and running. No reason not to use it at all. So I totally get that. Yeah, I teach too much. I don't have the time to learn and go in depth into the tools. Yeah, that's a completely, like, more and more I understand that approach, especially when I have to mimic the learner's environment. Oh yeah, totally. You want that learner's environment to be consistent and stable and as easy as possible to get up and running. Yeah, we've got teachers in the chat. That's really cool, by the way. I sometimes think that I would like being a teacher because I really like sharing ideas and explaining things. But I don't know. I'm not certain that I'd actually be good at it. But it seems like a really cool job. As of right now, I'm not. Oh, you were a teacher. Are you kind of in between things at the moment? All right, let's see here. Let's conj onto the tries list the new try. Okay, let's see if this is going to do anything for me. It might not. So we've got clip one ear working for some thing. Let's try clip ears and see if I messed up. Okay, so we've got okay, I think things are not working. So now what I want to do is build a little helper here. So let's do defen show triangulation. Sure. And let's do this. Keys, tries. And then we'll just do it quick and dirty. Let's actually do into. Oh wait, I don't even need to do that. Let's just do a for loop. So let's do for try and tries, okay? That's gonna give me a list of 3 things. All I wanna do here, hey, Codeplex. First time chat, how's it going? How does everyone feel? How does everyone feel about the old adage, those who can do, those who can't teach? Has some truth to it. I kind of feel like the only time I've heard that was when high school kids were trying to be mean to their teachers. That's the only time I ever used the phrase, to be completely honest. So, because I actually kind of tend to take the opposite view. I know for myself, when I can explain a concept well enough to, say, confidently talk about it on stream or make a YouTube video about it, that's teaching in some capacity. That is when I feel the most sure that I know the concept, you know? So, but what's more important, doing or teaching? That's actually a good question too in and of itself, right? If you can teach it, you can do it. That's actually a good question too. I'm not sure. I tend towards yes, probably, but I don't know entirely. These are interesting questions. You can teach maths. Cannot do maths professionally. Well, so fair point, Thrashton, except for, right, there's that like little asterisk. Professionally is maybe not the like, is that a fair measure of able to do it, right? You know what I mean? Like, different levels of knowledge. That's a good point, right? Maybe, yeah, if you can stratify knowledge and ability a little bit like that with different levels, then it becomes maybe a bit clearer, right? You can kind of teach at or below a level that you're at, but you can't then say you can do the level above, right? I agree with that with most things. With programming, it's a bit different. You can have an intimate knowledge of theories to teach, but you have no practical skill to service in the professional development world. I suppose that's true. I would guess that if you were teaching, like let's imagine let's imagine the perfect course and the perfect teacher, and the course was software development for real world applications. Like, let's imagine that was the name of the course, and let's imagine the course was well designed and the teacher was really good, right? If that were the lesson, probably the person teaching that course would have learned some of those things via doing it in a professional development context, right? So in that sense, if they're able to teach those skills, they probably earned those skills via doing it, right? So there's sort of an inversion there, right? It's not that, oh, because I can teach it, I can therefore do it. It's because I did it, I can therefore teach it. And again, that's not necessarily the case, because not everyone who can do a thing is good at teaching. So they're like orthogonal skill sets, right? Anyway, I don't know what I'm trying to say. I'm just trying to just trying to talk, I guess. These are fun things to think about. Right. What did I do wrong? That's a good place to start. Oh yeah, and I need to visualize it. Agreed. Unfortunately, colleges tend to teach the theories. Oh, sorry, I didn't say tend to. Colleges teach the theories 90% and then expect practical knowledge to be filled in through internships. Yeah, that's not the only, sorry, that kind of model and assumption is used not only in computer engineering and computer science, but in, like, I studied mechanical engineering, and it's a bit of a similar sort of thing. And there's a slightly fair argument to be made, like, okay, well, some of the practical things are very specific to what company you work in. So why would it be any school's responsibility to teach you how company A does something if it's different than company B and you end up working for company C, right? So there's an element of things being arbitrarily different from company to company, but the theory underlying it is, at least theoretically, the basis on which to build. So I can see that argument. I'm not saying it's 100% a good argument, but there's elements of reasonable perspective there, in my opinion anyway. But I think the real skill that is good for any person in any context to hopefully build over time is the ability to discover how to kind of learn on their own in a somewhat autodidactic way. So that means like figuring out what you know, figuring out what you don't, trying to assess what's important to know in a certain context. Thanks for the follow, Codeplex. Appreciate that a lot. Basically the skills to learn things on your own, or ask or figure out where to go, who to ask for specific levels of knowledge, those become really critical, I think anyway, because those, in my experience, tend to be the most transferable skills, right? You always need to learn some specifics about any position you're in, or any, even if you're not working, if you're starting a new hobby, you need to know specifics. But the skills that are helpful are those ones that are generally useful in the process of learning the specifics. You kind of need both. And I feel like for me, the things I learned most in school were the abilities to study somewhat effectively. Granted, I still need to improve on those things. The ability to figure out where the real important questions are. So figure out some of the things that are nice to have but not strictly necessary, and kind of piece things together from all of that information. It's kind of, you have to think quite creatively about knowledge in and of itself. It's fun stuff. Boy, oh boy, you got me chatting. Now I'm not working on my code. I love it. That's totally great. Keep talking, keep asking questions, everyone. It's fantastic stuff. Also agree with that. Very level-headed. Oh, good. Glad you think so. Did I say thank you for the follow, Codeplex? I think I did, but just covering the bases here. Okay. So I'm quite sure this clip ears algorithm is wrong. It's giving me triangles, but I need to visualize them. It's easier to draw it on screen than to just see these weird lists of points, okay? The reason I'm quite sure it's wrong is because every triangle has the same starting point here, so I must have done something wrong. I must have passed the wrong value in somewhere. Nice chat. Need to go lurk in the back, prepping for a meeting. Hey, no problem. Anyone who's listening and like if I say, hey, feel free to talk, no one is at all obligated to actually talk. I enjoy it. It can be a lot of fun. But yeah, you do what you got to do. If you're prepping for something, go right ahead. I'm just happy to be here, you know, part of your work, your day, whatever it is, you know. I appreciate that. All right, so for every triangle, we're just gonna render a polygon, element/polygon with the tri points. Oh, and we should apply a bit of style to it. Let's fill none and stroke white. That is readable on this. Is that gonna work? Oh, that's also. Let's wrap that in a tools cider show. There's for anyone new here, this is a pretty fun thing. So the Emacs has a REPL for Clojure called cider. That's CIDER. And cider can display images in line. So I used that to quickly be able to show in the REPL different SVG elements. So like that, I could draw stuff right into the REPL, and I think that's quite cool. So let me do, let me try this. Show triangulation of the clip ears here. Oh, it actually just worked. Oh my goodness, that is cool. So here's the thing, okay? The thing about this is it gets you a triangulation of a shape, but it can very easily and very likely lead to technically bad meshes. So if you see this here, there's a far better meshing approach for a convex shape like this, where the triangles don't get too thin, long and skinny. But this is quick and really easy, and it might be good enough for what I'm trying to do today. So the point is, I know that there are weaknesses to the ear clipping triangulation method, but it's not useless. Like, I can still make good use of this for certain 2D contexts, and for today, I'm feeling pretty good about this. But now I do want to make a convex polygon to test with, to see if it actually does work for convex shapes. So because that's a pretty important thing to try. So how do I want to do that? Let's see. Let me see. Let me regular polygon points. Let's do a radius of 100 again. We'll make it 3 points. Does this break? No, it does render the triangle. That's really good. So if I do 4, there should be 2 triangles. Yeah, 5 should be 3 triangles. Yep. Yes, this is... Alright, I'm happy. Let's do 70. Bump it way up. So this is where we see things slowing down, and that honestly is not surprising. So what I've just done here, this number here is the number of line segments. So it's going to look like a circle, and it's going to have tons and tons and tons of really bad triangles in it. But if it works, it should still render. I went pretty gung-ho on that. It's maybe too much too quickly here. But this is slow because of how, if you clip one ear, you have to check for every triangle, you have to iterate over every other point in the polygon to see if any point lies inside the triangle. This should terminate. I sure hope so. Because it's purely convex. I haven't tried a concave situation yet. So other things I haven't checked yet. This was literally just the first pass, the naive approach that I did. There might be situations where it can get caught, like in a non-terminating case. I don't know. Like if clip one ear somehow, I think it should always return a single triangle. But maybe I'm wrong about that. I don't know. You know what? Let's kill that. Let's go 20 instead. You know, start a little easier. Went a little crazy there. I'm surprised that it's okay. Let's go back to let's try 4 again. Okay, so it is, there's things are still kind of going. Something goes weird here. I feel like I've done something wrong. Like maybe it's not actually taking a long time to compute. It's just failing now because 8 is nice and quick. Okay, so what have I done wrong? That is the question. Well, let's do something like this. Let's clip one ear, okay? Let's change this up too, just a bit. That way I can do this. I can do clip one ear. Yeah, okay, so it does still work. It's just super slow. Okay, so clipping one ear seems to be working. I don't know why it would suddenly start to go slow here. So let's try to figure out what I can do with that. It must be getting caught on something, right? Like, there's just sort of an implied assumption somewhere in this clip ear that isn't holding like I thought. Let's also, okay, so let's kill that. If I do count A, okay, so if I do that, so if I do count tries from clip ears of A, 7 triangles. Wait, is that right? Let's see. Ooh. That's weird. Why did that happen? Right. Okay. That's because of this. That's my mistake. Okay, so I have to, since I changed the signet or the data structure layout here, I just have to incorporate that change appropriately into here. So now that actually does mean that should be okay. Here, let keys, new points, and tries. There we go. Now I called the key tries instead. And now this should actually be concat. Oh, this is gonna be pain in let's go back to this. Try is try. Okay. All right, now we should be back in business with that. There we go. Okay. One, two, three, four, five, six. Is there a redundant try? There might be a redundant triangle here. Let's see. Oh. This is just wrong. I don't need to... I actually can just return tries like this. There's also no point... Well, I'll leave it that way because the function's not done. I'm not convinced that I've got a good data structure here yet. 1, 2, 3, 4, 5, 6. Yeah. Okay. I also... I don't think this is necessarily a good idea, but I want to try do this. Shuffle. And now I want to see what happens. See, that's kind of cool, right? Because I get random, like, look at that. That's actually a cool, like, that's a pretty fun triangulation. The problem is I don't want it to be random, right? I do wonder if there is a way to kind of get reasonably good results without making the algorithm any different, really. Uh-oh. There we go. I don't think that's the issue. Oh, I should check this though. If I do regular polygon points 9. Okay, that is 9 points. That is obviously not surprising. But if I do this, remove collinears. Okay, it's not that. So it's not an epsilon problem. I should also probably have eps be like a global dynamic binding that you can change like per invocation. But I'll have to think about that. Whoops. I'm dropping things here. That's not good. Okay. What could be the problem? Well, okay, let me... If count of points is less than 3, or let's put in an extra stopping condition here just to try and get some insight into things. Count of tries is greater than 100. I don't know. I don't expect that to be what's going on, but I mean maybe. Null. Really? Okay, well let's do clip ears p regular polygon points. Okay, that works. 9. Okay, so we've got a whole bunch of something. So this means what? Ooh, interesting. Okay, here. Let's also, okay, I should get rid of the shuffle here, by the way. Just Yeah, I'll get rid of that. Let's do this as. Okay, well, let's take this out because that's the correct stopping condition, but let's put a little if around here so we can get the data out as it fails. So what I can do here is if so I'm conjing try onto tries. So what's happening is I'm getting nil here at one point. So what I want to do is if try if nil try, right? If it is nil, yeah, that's what I'll do. So if it is nil, I just want to return as data. I want to return data try endpoints. That might be a bit of redundant data there, but I'll go with it because why not, right? It's useful. Okay, so it failed and we get this data. What? Oh, it is totally redundant. This. Okay. So the points that went in, and then the new points are actually the same because there's no triangle found with these points. So let's have a look at what these points are. How about that? Okay. Okay, so this is failing. Not sure why. Let's see. Count B, 5. Let's do remove collinear of B. 1, 2, 3, 4, 5. Yes, so there's no collinear points. This is peculiar. There's nothing immediately obvious to me. I'm sure, I mean, I'll get there, but I don't see it yet. That's the truth. There might be something wrong with, it might be failing convex testing. Let's try that. So let's do map corner condition over B. Oh, right, I have to That's a little bit silly. Let's do map. Ah. So the winding order got swapped, I guess. Because if I do this, okay. I'm surprised that the winding order gets swapped around like that. That's what's going through my brain right now. That's what I'm trying to think about. That confuses me, but let me let me implement the first thing I'm thinking of at least. Let's do a little pre-process. That's not, so this is not a real solution. It's kind of a hack just to see if things work at all, and then I'll think about why my algorithm, my approach ends up with some with the winding order switching like that. I don't know why yet. This might actually be okay. Theory, don't know if it's true, but the theory is the order of lists. No, what is it? Clojure data structure order guarantees. Here's the thing. I think if I do something like zip map range 0 to... Okay, let's do range 0 to 8 and range 0 to 8. Okay, so here I've constructed a map with 8 total points, and you can see that they're in order. But I think if I were to do like let's go up to 9 now. Okay, here we are. This, I thought I had set it up to handle this, so clearly there's something wrong with my thinking. Okay, here's what's happening. The order of a Clojure map is not guaranteed. It, by circumstance of implementation, will always be sequentially ordered, as you might intuitively think, for small map sizes. So clearly that's about 8. Once I popped up to a map with 9 entries, the order is not guaranteed. The reason is for implementation details, it guarantees a certain retrieval time, so it's an intentional thing that the order's not guaranteed. But I accidentally required, in how I set this up, I accidentally required that the order be guaranteed. In one of my assumptions, I was not thinking about it correctly. So that's related to how I am trying to reconstruct the indices from the original points list. So I'll have to rethink that, I'll have to revisit it, but that's where the problem arises. If you do this, you can see it. I mean, it happens to be consistently the wrong order. There's nothing wrong with it. It's literally just that it's not guaranteed. So you shouldn't count on it being correct. Okay, so that's why it falls off at 9 right away. That's why things nil out like that. So let's make this little helper function to at least see if things work for larger numbers of points. And then I'll kind of go on from there. So let me put a little note to myself though. Note, something is wrong with my indices retrieval, causing the order of points to be incorrect. Winding changes. When the entries in a map are above a certain size. We see this falling apart at a polygon with 9+ points, because at that point the map entry order is no longer sequential. This just means I need to fix my indices implementation. There we go. So now I know why it's going wrong. I know a quick fix, I think, and then I can fix that off stream. I feel okay. So this is a really fun example of this is something that could totally confuse someone who's new to Clojure, right? Like, how on earth would you know to even think about this kind of an issue, right? That after a certain point, after a certain size, that the map order starts to swap around on you like that. I mean, maybe programmers in general start to think that way, but if I were brand new to Clojure, this would be totally confusing to me. So that it makes me feel like that little bit more confident that I've actually gained knowledge and competence in Clojure over time, that I was able to, I mean, granted, I haven't solved the problem yet, but I've identified at least one element of what's causing issues. So that feels pretty good. I'm happy with that. I'm proud of myself for that one. Right, so the reverse if all reflex thing is pretty simple. I have to change this. I'm trying to think of like the most appropriate way to handle this. I want to well, I have to do it this way actually. This is not so hard actually. Okay, here's how I'm going to do this. Well, I have to do, I'm going to map apply corner condition no. Man. Okay, I'm starting to confuse myself. I was getting a little too clever here. Okay, so the corners are just this partition approach. That's all it is. Okay, super simple. In fact, it's a one-liner here. Partition 3, 1, concat, points, take 2 points, blah, blah, blah. Okay, that's the corners. Then I want to process the corners, okay? So, reverse if all reflex. I can do like this. Reverse if all reflex. Hey, how's it going? Cyranonymous GT. Sorry if I get your name a little bit wrong. I do my best, but you know, it's the internet. People have names that are sometimes hard to read. Can I take part of your time? Probably. I mean, it does depend, but what's up? What do you got? Maybe I can help you out. Let's take the corners here. Right, so what I want to do here is actually map. Well, first of all, let's do let conditions be map. Hey, C Films. Glad you're doing well. Good to see you. Cyranonymous, not sure if you heard it, but go ahead if you have a question or something like that. Feel free to put it in the chat. Maybe I can help you out. I think it would be easy for you. I'm doing a project about Cisco Packet Tracer. It's a course for networking, and I have a problem sending information out to the router. Are you working on creative code and code art? C Films. Yes and no. So, excuse me. What I've been working on today was an ear clipping algorithm, which I can actually show you here. Let's see here. Okay, here. Oh, So here, I'm working on an algorithm to split polygons into triangles, so a triangulation algorithm. I have a Delaunay triangulation that's really useful, but it doesn't work for concave polygons, so polygons where some of the corners go like this instead of like this. So I need that ability. I need the ability to triangulate concave polygons for my creative code. So I'm working on that algorithm today for the purpose of using it for creative stuff. Here's an example. I need to be able to do triangulation of the surfaces on the tops and bottoms of these extrusions. To briefly tangent, and let me render a different thing here to show an example of where I need this concave triangulation. Okay, Sir Anonymous, you're doing a project with Cisco Packet Tracing. It's a course for networking. You have a problem sending information out of the router. So is this a homework assignment that you're working on? I will say, if you have specific questions, I might be able to help you. There's two things here. One, I'm not a network engineer, so I maybe can't help you at all. Sorry about that. And two, if it's a homework thing, it is honestly better for your own learning if you kind of struggle through it and try to figure it out. So I cannot do direct answers, if that makes sense. But if you have some sort of specifics, like what you said there, I can't really build off of that. So if you have a little more specific question to build off of, I will gladly try to point you in the right direction. But I cannot do your work for you, to be blunt about it. And I'm sure that's not too surprising for you to hear. I'm not accusing you of wanting me to do your work, to be clear, but just so if it's copy pasted like a question from a textbook, I won't be able to help you. So I hope that's okay. Right, so C Films and anyone tuned in, this here, it's a low res render of it, but this, if you look at the very top of this, you can imagine this being traced out as a polygon, right? All the jagged edges there. And I can't run a Delaunay triangulation on that because it'll accidentally put some, like, it'll fill triangles over the gaps and give an incorrect result. So I need something that works quickly with concave polygons, and the first implementation I'm working on is called ear clipping. It just cuts off triangles one at a time. If it's convex at that point and there's no other intersections, then we're good to go. It's very simple. It doesn't give you good meshes, but it works quickly. Gotcha. I'll try some things to make the function. Come back later with specific questions. Sir Anonymous, I might not be streaming for too much longer, so if I'm offline and you come back, apologies. But thanks for asking. Good luck with the triangles. Yeah, thanks. Hey, good luck with your assignment. I do hope it goes well for you. I bet you'll be able to figure it out. Just give it some time, give it some thought. Maybe you might find more detailed responses on like blogs if you search more carefully with search terms and stuff like that. It can be hard to give good advice on a stream, so I'm doing my best, but best of luck. Okay, so where was I? Over here. Thanks, yeah. Also have a lot of time to search for the solution. Great. See ya. Yeah, thanks for stopping in. Thanks for asking. Have a good one. Best of luck. You'll do just fine. You'll do just fine, just fine. Okay. Let's get this ball rolling. let's change this up a little bit. This name is wrong. There. No, I can do this way more compactly. Seek. There we go. Okay. So now I just do this. Corners is going to be that, or getting some spam here. Sorry about that. All right, I think that's good. Okay. Yeah, let's just do it the naive way. I'll fix it all later. So if no convex corners, if that's true, right, then what I have to do is this. I have to reverse this. Otherwise, it's just corners. Then, since this is messy anyway, I'll just keep it messy. So corners now, all I want to do is filter Yeah, I'll do this. So I'll filter, it's the same. Okay. Didn't work. Okay. Well. Oh, okay. So I should call it convex and then invert the logic. It should be any convex if any convex, yes, corners. There we go. Okay, that should fix that. All right, now we should get something, I hope. Oops. Right. Okay, there we go. So we've got a new clip there. So let's try get this back in business. Maybe it'll work. Let's try this. Let's show this triangulation. Okay, so that works for 8. We know that. Let's try 9. That's cool, but wrong. Okay. I'm gonna be right back. I won't be able to solve this on stream today, but I need to clearly need to have a better order preservation approach. Just reversing things willy-nilly is clearly not going to get me the right result. That's not good. It looks super cool, and it does give me every point is in use, but it just breaks the assumptions of the algorithm. So no good is what I'm getting at here. All right, so I might actually have a better approach, but I'll think about it and I'll be right back. right, here we go. Hey, private final int. Thank you for the follow. I was just going to the washroom for a minute, and I came back and I saw that you followed there. So thank you for that. I appreciate it. I hope you're doing well, and welcome to the stream. I just realized I might have a simpler solution to this particular issue than I initially realized. Since really the problem is with ordering of the point list, I realized what I might be able to do is just when I reconstruct the new points here, what I should do is actually sort these vals so that the indices are in increasing order, and that might actually solve the problem. We can find out. That solved it. So much easier than I thought. That is fantastic. Oh, look at that. I mean, it's horrible, horrible triangles in the when you get into this section of it, but pretty cool. I gotta say. Oh, that was way easier than I was making it out to be after all. That was a little bit silly of me. Sometimes it takes stepping away for a minute, like literally just a minute, to find the solution to the problem. So, feeling good about that. Now, a good thing to do is see if it works for input, like for concave polygons. Let me see, how do I want to do it? Trying to think of what I could do here. Show 2D of that's a fun shape. There we go. That'll be what I want to do. Okay. Let's do that. Okay. There we go. So the points is just going to be map f range 0 to 1, 0.01. So it's simplified. Okay, so let's do show 2D concave. There we go. So fairly simple thing. Now let's try show triangulation of clip ears of concave. Yes, it worked. Okay. Whew. That is great news. I'm super happy with that. Okay, so let's, now that I'm pretty well on a roll here, let me do this. Let's pop that up into the, oh, no, I need to do this. Okay, so we've got this here. Let's do, okay, now we can test. Hopefully this works. Let's let these triangles be. Ah, okay. What time are we at here? Right, so here, does my show triangulation helper, will it work? Okay, it works with that. Should work with alg triangulate, right? It does, okay. So right here, you get kind of nicer looking triangles, but you get triangles that go beyond the bounds. So it's not what you need. This is the Delani, and this is the ear clip. Okay. Let's get this tri-indices thing working into the data properly here. Okay, so all we need is to capture that into the data structure. Not actually that difficult. Okay, so what I want to do is like this. Is that actually how I want to do it? It's a little clunky. But I do need to initialize it like this. Points is points. That's fine. That's fine for now anyway. Okay. So the reason I'm doing this here is I want to save into the data structure that's ultimately returned. I want to save the original input points so that a user could use that, like they could trust that they're still going to be there. So what I actually want to do here is I want to end off, oh, sorry, let me think about this. Data, points, tries. It's a little messy. I'll clean this up later. I can't really, I just want to get it working and try it in the context of this 3D shape to see if that'll work. Because if it does, then I can actually start to build my own OpenSCAD thing without necessarily needing OpenSCAD to do the visual rendering. But that, I'm getting ahead of myself. It's important that I have triangulation working in the context of my Clojure code, not shelling out and having OpenSCAD doing the triangulating. That's important for the stuff I need. So clip ears working is a really important first step. Okay. Almost done for the day. Just getting this working. Points, tries, try indices. Okay. So here, there we go, like that. Get rid of this. Okay, is this correct? I need, oh, I also need to pass data in like this. Recur with data. Points is new points. Try list is you append try onto tries. Indices is you append try indices onto indices like this with conj. This can be deleted. Okay. Let's see if that's the way it's supposed to be. Let's first of all, so let's go up like this, show triangulation, alg triangulate. Okay, messed something up there. That's okay though. 1, 2, 3, 4. 1, 2, 3, 4. There we go. So now it should be working. Let's see if we can drop in replace this here. So this is the volume function. What I've got here is the triangles forming the middle part of the shape, the bottom tries and then the top tries. So bottom tries and top tries are currently being triangulated with alg triangulate, which is the Delani, which it won't work. So I'm gonna just drop this in and see if it works. Let's find out. So we'll have to wait for this to render, but we'll see what happens. So it's loaded it, and now it's compiling the changes. Let's see if it's valid. That's a bit of a nope there. is pretty cool. It's clearly wrong, but it's pretty cool. Whoops. Well, that broke it. Okay, let's do this now. First of all, let's do A. Okay, so there's something quite severely wrong. It's pretty cool, but it's pretty wrong. Okay, so that means I've got work ahead of me. Oh, okay guys, I have to go. It's been great, but I have to handle something now, actually. Yeah, I gotta go.